This is part 5 of section 1.1. This is the last little topic in this first section. You're going to be asked to decide whether these equations represent a contradiction, a conditional, or an identity. The easiest way for me to explain what these are is to work one of each. What you're going to do is you're going to approach it just like it is a regular everyday problem. Over here, I'm going to need to combine like terms. And on this side, I'm going to need to distribute the -2. So I get negative 4x minus 11 is equal to negative 4x plus 6 plus 4. So combining right here, I have negative 4x minus 11 is equal to negative 4x plus 10. Now you might see at this point that you have something a little bit weird, you might not. So I'm going to keep going on a step. What I would need to do to solve this is I would need to move my x's to the same side. So let's say I'm moving this one over here. I need to add 4x to both sides, and I do that and it cancels out here, and that's what I want, but it also cancels out over here. So what I end up with is negative 11 is equal to 10. Now your variables went away, so you have something kind of weird, and that's pretty much true throughout this course. What you need to ask yourself is this true or not? Is negative 11 equal to 10? Of course it's not. So this is a contradiction. Originally this says this equals this. What we found out is this can never equal this. There is no value of x that I could possibly plug in that would make this thing work out. So another way we would say this in other classes, you might say no solution. And you may have used that symbol right there to show there's no solution. In this class, in this section, we call it a contradiction. Later, this will come up again. Okay, so let's try this one. To simplify this, I need to distribute over here, and then I will need to combine like terms. So I get 3x minus 5x minus 20 plus 10 is equal to negative 11 plus 15x. If I combine right here, 3 minus 5, that's a negative 2x. Negative 20 plus 10 would be negative 10. And recopy the right. Now let's get our x's together. Let's say I am going to add 2x to both sides. That cancels. I have negative 10 is equal to negative 11. That's going to be plus, so that's plus 17x. Now let's move the 11 over here, and by adding 11 to both sides, that gives me a 1 is equal to 17x. Now divide both sides by a 17. And we get x equals 1 over 17. Okay, so this is a regular problem. We got an answer, okay? This and every other problem we've worked besides this one has been a conditional. And what it's basically saying is this equals this, but only in certain circumstances, only when our x is equal to 1 over 17. It doesn't work any other time. So that's the conditional. In this section, they're going to ask you to identify contradiction, conditional, identity. And when it is conditional, they're going to ask that you give the condition. The condition is that our x has to equal 1 over 17. And it's not because this is a fraction, it's not because of anything else. If I got any answer here, it would be a conditional, and I'd write my answer inside those little squiggly brackets that are technically called braces. okay? They don't have to be pretty. Just one of my professors called them squiggly brackets, and they tend to look like that. Doesn't matter. Okay, so this last one. Now, I told you I was going to work a contradiction, a conditional, and an identity, and so process of elimination, this has to be an identity, right? But it looks like a regular problem. Let's just distribute here and then right here. So I get 8D plus 28 is equal to 2D plus 25 plus 6D plus 3. Let's combine like terms over here, recopy the left-hand side. 2D plus 6D would be 8D. 25 plus 3 is 28. Now, you may notice here that you have exactly the same thing on both sides, okay? As opposed to the contradiction where we had the same x term but different variables, different constants. Here, it's precisely the same. So you can tell at this point that it is an identity. Okay, it's exactly the same. They are identical. Now, if you don't recognize it here, and you go to move the 8D over here, you're subtracting 8D from both sides, then you end up with 28 is equal to 28. And you should definitely realize something weird's happening at this point. Your variable canceled out. Here, 28 does equal 28, so it's an identity. This did not equal, so it was a contradiction. Now, what this is saying is this equals this at all times. This is all real numbers. Any number we can think of that we could plug in here, we could do the arithmetic and it would be identical. Okay? You may have seen this symbol before for all real numbers. If we have a written assignment, I don't mind seeing that, but and you're going to be doing your homework in MyMathLab, and you'll just click a button. Okay? This is the end of 1.1.